Okay. Um. Hi everyone. So apparently, after some sleep, I realized two things. First of all, that I think I made my video way too long, and they are in and the information is kind of spread across all the video, and it's hard to connect everything together, which is I think it's not very helpful at all. So yeah, for I think from now on I will try to before I make a video, I will try to organize all my idea and talk about it in a condensed way so that many of us will be able to understand it. And one more thing, that I think I should not stay up late at night until 3 a.m. to do the project, which is not good. I think in part A, I think I finished very early at around 12:30, and then I go to sleep, which is actually very refreshing, and my brain was able to have a good break. Yeah, and in part 9, well, yeah, I did the same mistake again, and I went to sleep very late, which is make me very tired. And the results that I had to add ChatGPT for the idea because I'm just so tired. So yeah, this is part A. So in today, let's see. For today, I think I will work on the event. When we click on the square, it's going to accept the test, and we can enter something. Yeah. Um. So in the last one, I think I wrote this in the if else statement. So I think I will rewrite in the case like this. So yeah, mouse location. I think I can use the mouse location like this. Event type. SDL3 mouse location mouse. So yeah. So this is what I did. I access the event. When I event quit, mean that I press the it means that I press this button, it's going to close the program and release all the memory. Very basic. And so the next one I want to add is mouse clicking. So mouse clicking is that, and when we click into the square that we initialize, yeah, in this area, it's going to accept the test input. So how do we know the location of the mouse if it's inside it? I think the answer is kind of simple. You can go to this one, category mouse, and you go to event mouse button. No, you go to event mouse down in here. Event type. Go to event type here, and in that I think you can access. No, not here. Oh, category API. Go right here. Event mouse down. How do I get there? Oh wait, no, just go to here, go to the end mouse. Oh wait, that's a loss of function. Data type. Oh man, I don't really know where's the mouse one. Oh, right here. SDL mem CPY mem. Oh, I think instead of using memu, we can use the SDL memu. So yeah, so by doing this way, SDL will be able to work on a lots of machine without any error, because on because every um, a, a computer is not the same. So if we only use memu, it might work on my laptop, but not be able to work properly on other people machine. So by using SDL, the old function SDL, I think they kind of make it portable for majority of the machine. So yeah, that should be it. How do I find the thing? Scale IO, set Windows, web. Oh, how do I find it? How do I find the event mouse button down? Yeah, event type, event quit. Event quit. Mouse button down. Enum. I think go to the enum right here, right? No. Event mouse button down. No, this depends. I think, as I remember, I think I watched it on YouTube. Please mouse example. I think I might check. I think I watched his video. Here, mouse event. He's using mouse C++, and I'm using C. So the typing might be a little bit different, but it's generally the same idea. Yeah, let's see about this. I want to be a software engineer? Nah, I want to be a filmmaker. Yeah, so he get the mouse SY event motion. He used the motion. Yeah, so if we click on it, we have to check if that one is in this region of this rectangle. So event motion.s is greater than, so we check for the s first. This s should be 200, because right here width by 4, so 800 divided by 4 is 200. So rec is greater than f rec.s, and event motion.s less than, this should be less than this coordinate right here, which is how wide is that? Like 200. About 200 times 2 is 400, and we have to plus this one because it is in this one. So 200 plus 400, it should be 600. It should be 600. fbrec.s plus fbrec.y, fbrec.y width. If this is the case, so it should be, if it is inside this, but we need to also check inside this thing as well of the height. And if event motion motion dot y greater than frec dot y, frec dot y. Yeah, so it should be here. It should be like 200 and the 200 plus with the height, and event motion dot y less than frec dot y plus the frec dot height like right here plus 50. So it should be in this range. Yeah, because if that's the true, we will trigger the STL open input, STL3 open test input. We're going to open the test input. Yeah, you go to check this function. Yeah, you want to check this function started. Oh, I think before that we want to do one more thing. Static bool accepting input equal to, yeah, so why do we do this thing? Because we want to click this, and it's going to, when we click it, it's going to accept, and we click it the second time, it's going to not accepting it, like we are closing it, something like this. If we click into this, we was able to type in something. If we click one more time, it's going to be it's going to cancel it. Yeah, it's going to cancel the input. That's why we want to have this bool. So accepting input equals let's make it false. Yeah, let's make it false. Yeah, and we check one more condition. If accepting input equal to this, if this one is not true, if this one is true, if this one is true, then we're going to accept the, we're going to call it function STL stock. Wait, let me just type in here STL and this one. Yeah, and we try to slow down and explain clearly what I want to do, and try to make my video as informative as possible and as condensed as possible. Yeah, I don't want to do like a 3 hours video. Yeah, no one will watch that. Yeah, I think that's my mistake in the last few video. Stock test input, stock test input window. Yeah, accept the window. Yeah, we have to check. You have to check if this one is good. This one is good. You have to place the condition. Do we use if? I think I want to be a little bit careful with my design choice, because you know, I read on the internet that I think I watched a video 2000 ago, 2000 ago compared to 10,000. I think I want to expand that, and I want someone else to be able to read and maintain my code in the long run. So I think I will try my best to make it readable scalable and maintainable. Yeah, first entire. I think I watched this video about the short can first 2000 lines of code dictate the later 10,000 lines. Oh wait, yes. I think it should be it. Yeah, if you dictate 10,000 lines. Architecture foundation and coding standard. So yeah, I think I want to be a little bit careful with writing this if like this. Should I write this if like this? I think I will make it work. Then I'm going to refactor it later, but I won't forget about this. Yeah. Let's see. Accepting input. How about I make a local and if let's see, check if we are currently we are if not accepting, yeah, if we are not accepting input, then we'll open to accept input. Yeah, I think I will write this command right here. Accepting input. So we're going to open this function STL start test input window. If this function fails, go to BS call STL log couldn't open test input. Go in test input. Couldn't accepting Unicode test input event in this window %s new line STL get error yeah and then if this is the case, then we're going to make this accepting input equal to false, or if the function success, then accepting input equal to accepting, and one more condition, and if we are accepting input and we are click into that window, then we're going to deny the input. Then we are going to not receive it. Yeah. And then we're going to stop receiving that. Stop test input. STL stop test input. This is really true. I hope this will work. Yeah, then we are going to not accepting the input like anymore. False. Yeah. Cool. Then how do we accept the test? Yeah, how do we accept that test? How do we type in that? Oh, I think yeah, let's see. Just to make sure that it works, let's as the let's try to print to the terminal. Accepting text input. Yeah, let's write to the terminal. Ring F. Start with accepting text input. New line. Yeah, I think let's try it. Let's see if this one work. I think I need some feedback. If you know someone who good at this, I think I will openly accept the feedback. Well, it might be hard to hear, but it is the part of the process. I think we pushed my code on GitHub, and yeah, let's see how will they do. Let's see. Let's run it. No error. Cool. No, nothing, right? Let's hear. Accepting text input. Stop accepting text input. Yes. Oh yes. So this is how it works. That. Okay. From now on, I will try to have enough sleep. Yeah. I'm so much happier to have some enough sleep. Okay. SDL3 test SDL3 test input. That was the tutorial. I think I need something to reference for my code. I can try to figure it out myself, but it's going to be way too long. Here, this one right here. Even though it's SDL2, it will have the same idea. Yo, let's see. It's 22 minutes and 55 seconds already. Okay. I hope my battery won't hurt that much. Okay. Academy sport and outdoors. Very cool. Coding made easy.
If the key that we press.
Okay. Accepting test input. Okay, so when we accepting the test input, right? So we're going to check this one. Go to this case event test input. Go to make this event type. Can we make a case inside a case? SDL3 example. Should we really do it? Well, I think we don't have to, because I think I saw an example of this one on the official website. Here, let's make this a game right here. Can we do it? Ooh, I think it should be this one. Wood and I. Let's see. No, they only use F. Oh. Yeah, I think we should not use the case in here. Yeah, and we go to check if the key is down, so we're accepting test input. Because we are accepting test input, right? So to check if event can we make a case can we make a case inside a case of switch statement? Can we make a case inside a case of a statement? Yes, that's a switch statement. Ah, okay. So going to do case. Yeah, we're going to case STL event. Wait, what is the key code for test input? STL event test input. Oh, here, test input, keyboard input. You're accepting the key. Event test input. Oh wait, no. Oh, we cannot really do it. Oh, how about we use it instead of if we use the K? Can we really do it? Oh, my bad. Oh, my bad. Oh, no. Yeah, commenting all of that. I think you use a control. You use window and slash. Yeah, we can do the case. Case. Oh, I think we cannot use the case inside. No. Can we? No, why it doesn't highlight? Something is not right. I think we should we decide this way? What will he do about this? Oh, he used if. Can we make it work like this? Why is it not working? Case. Did I make some mistake? Can we do a case? Ah, yes, it's. Can we do a case inside an if inside a case in the switch statement? Can we do a case inside if inside a case? Oh. Oh, we have to use width first. Okay. I think that makes sense. Yeah, I think we can use width. Width event type again. Should we really do it? Because it might be confusing. Should I really do this? Should I do this instead of an if? Yeah, I think I can try this one. One case. Yeah, case. STL test start test input. SDL start, SDL event test input. Can we do it two? Can a case have two conditions in switch statement? I think you can do that. Case. No, it's way too confusing. Let's just use if. Should I use an if? This work both ways. Can I do it? Should I optimize it or just make it work first? Oh well, let's just use an if. This input case key down. Wait, what is the key down? SDL key down. Oh, here. Key press. Oh, okay. Should I use this? SDL event key down. Event key down. So this means that we are pressing a key. So we are pressing a key. Let's command it. Accepting input and is pressing a key. Yeah, can I do it? This doesn't sound very natural at all.
First of all, before we even check the key that we pressed, we're checking for two different events right now. So we want to make sure that we're actually using getting the right event. So we're gonna say if the event type is SDL key down, and the key we're getting is equal to
no, let's use if. Yeah, let's use if. It's way easier to understand. If event type equal SDL stock SDL event test input event test input or event type. Oh, I think we can use the motion right here. No, we don't need to. Event type equal SDL event key down. So we actually needed a key code, something like this. Initialize the key code. Yeah. SDL key code. This one equal event key dot key. Keyboard ID. Yeah. So gonna check one more if.
SDLK backspace, and the length of the text is greater than 0.
Oh, he's trying to implementing the backspace so we can delete the key. Okay. Okay, so we're going to check one more thing. Check if we are pressing backspace or not. Okay, if event type go STL key down and pressing the event key dot sm equal STL. Wait, what is the backspace? Wait, STL key code. Yeah, let's check for the key code. Yeah, 45 minutes, not too long. Right here. Now we write the backspace. Here, STLK. One more, and we only need to delete the work if the length of the input buffer is greater than 0 is greater than 0. Input buffer greater than 0. Yeah.
Then we're gonna say text is equal to text substring.
I think you see the plus, but he had that make built-in function. We don't have it, so we're going to use this. Delete work. So you're passing input buffer with the work, with the last work of the. I think we can take the last work of the string we want to delete, because we want to delete the last work, right? We need to pass in that. So we got s3. So input buffer. The last word should be the length. cr length. Wait. Okay. Wait. Chart last work equal input buffer str length. Wait. Let's not abstract it a lot. Length equal str length, the length of our string. Okay. str length, no, let's use length -1. Well, if we use length here, we're going to get the no terminator, because the last word is a no terminator. So we're going to subtract 1. Yeah, delete book input buffer. So we're going to pass in last work. Yeah, I want to make sure that this function works properly. Yeah, let's see. No. Key event type. How do I think I don't know how to do it. This one's not correct. He used event keyism. Is it correct? No. There's no member keyism. How do I access that? Oh, wait, no. I think they have it in here. Kiko. I don't need to do this. I just need to write if we press that, so it's going to be this one. SYM. Yeah. Test accepting input. So far so good. I think everything worked perfectly fine. Okay. Let's just try to finish that and go to test it out.
0 text.length.
We don't have to care about this because we already have make our own. Here, this is how we make a function at the top. Try to delete the last word. Yeah, we're going to take in the string and the last word. Get the length. Find the word in the string that need to be deleted. Need to be removed. Yeah, I think so far so good.
One, and that's just gonna erase the last letter from
the
end of the end of the string, and then we're just gonna say, okay, else if ev.type is equal to stl text input, then we're going to add to the text, and we'll just put the clear screen at the top, and we'll have the CR at the bottom. Now
we're going to add the test into it. Going to add the if test input. Okay. And else if we are if we are not if we are not pressing the backspace but just the test input, event type equal STL event test input. So we're going to add the last, we're going to add thing, add chart. Yeah, we're going to add to it, add chart. We're going to add the new word to our string, add chart input buffer with the key that we present, key that we enter.
Why we have to say we can't just put else, we have to put
yeah, and then we're going to print it. Then we're going to print %s input buffer. Yeah, input buffer right here. Let's see if that works. Okay, accepting test input right here. Oh wait, no, why it isn't accepting it? Oh, my bad. I have to update that inside the main right here. Okay, like this, like this one. If this one work, what? Do we have to clear the screen? Oh, what? Why is not printing anything? Did I have something wrong?
STL text input is that if we just put else, whenever we the backspace is considered a key, so it's just gonna say, okay, it's not this one, right? but you still enter the key, so it's gonna try to add the backspace to the text, which obviously doesn't. The ASCII value is a weird symbol, so that's not what we want. So we're gonna say, okay, if the type is text input, which
system clear. Should we system clear? System clear. Oh no. Oh wait. In the app, let's send C SYM. I don't know. Maybe this one work. Oh, it's gonna take a little while to initialize it. Oh, okay. It's wait. Why is this not accepting? Something's not right. Why doesn't bring any buffer? Oh wait, why is this accepting input? Huh? Does this work properly? How do we know? Then as input buffer. Wait, how about we print it outside like this? I think it's the order matter. CD window. Yeah, okay. Let's see. I think it's the order that matter. Why is not printing anything? Oh wait, because it would never trigger this event. Yeah, let me. I think I don't know how to do it. Keyboard event.
press any just see what we get. So my aka something.
No. Yeah, I think. Yes, I think it's good to ask ChatGPT about this. I think it's know way more than me. Yeah, I think I should add it. Yeah, nothing embarrassing about that. Just cannot figure it out. So just ask for a hint. I think if I had my teacher, I'm going to do the same. Yeah, maybe I should not be feel good about that. Yeah, will this accept my input on the keyboard in my assembly event? Asking a question. Can they actually run? Ah. Oh, I didn't handling them. Is that so? Oh, because I never handled that event. Oh, because I think I understand. So I think it works like this. I only accept the input if I click on the mouse. So I have to be continue clicking in order for it to work. Yeah, something like this. Oh, it's only work when I so basically I have to separate this event into another case. Oh, oh, okay, thank you. Thank. I need to separate the input key in another case. Thanks. I need to separate input key into another case. That's why it's not work, because this is inside of this event button down. It's only work if it only work when the moment we press that mouse down. So yeah, I get my logic is kind of really off. Logic's really off. Yep, my logic is off. Let's commenting this out. Accepting test input. Else. Yeah, let's do an else right here. Let's do an else. I think it's good to do an else right here. If this one is true. Should I do an else? If this one is not true. On the trigger, the one is not true. I think I understand. If this one is false, so it could terminate. But if this one does not trigger, it will always trigger this else. Okay. I think AI is really good at good at giving information. Yeah, I think I should give it this kind of information. 35 minutes, kind of long. Else, yep. Accept an input. I think we only choosing false, right? So let's use else, because if this is not the case, then else this is the case. So we only need else. Yeah, we need else. It should be good. Stop accepting test input. Okay, we need to break the case. This one without this. Yeah, we need to break that. Break. Okay. After we break that, we're going to have another case. When we click the right now, the left mouse to enable or disable test input event, and then we're going to use that. Yeah, I'm going to use another case. Should I? Okay, case event test input, STL event test input, key down or key down. Oh, I think we have to use the key down to take the input. And now let's just this one. If it is accepting input, I have to check this one. If it is accepting input, this one is true, then STL key code key SMY equal key event setting the key this is the key that we accepting, and one more if, and if we are pressing the backspace equal SDLK backspace and SDR. Oh, I think I don't need to. Let's have this string length in input length input buffer. Yeah, it would be something like this, so it's more easier to read. Input length greater than 0. If this is the case, then we're going to trigger that one at the capture last work. Last work equal, we're going to get the last word of that one, str length input length -1 and we're going to call the function to delete the last word of that buffer. Does it hard? Not really. Doesn't feel very hard. Yeah, delete work. So input buffer length. Oh, okay. Last work. Cool. Delete the last work. Okay. After all of that trouble, yeah, we need to break that, to break the case. Put this key down. Can we group this 1, 2 together? Yeah, let's ask this question. What is the difference between SDL event key down and SDL event test input? Yeah, I want to know the difference. Oh, this one's the physical key press. File every key, test the language, key down, delete the key, actual test. U key and the shift detect control key. Won't detect control key. Oh, I think it's if we use the test input, will not take the enter, backspace, or arrow. Okay. This will trigger every key on the keyboard. Included control key slash shift backspace. It is an enter. etc. Cool. So that's how it works. Should we break it? Yeah, we need to break. Yeah, we need to break that one. And we break. And case STL event test input. If accepting input, if we're going to accepting that, so we're going to add a character, add chart, input buffer, and event test. Test 0. Hey, what is event only take test input basic key like character and not control key like space, enter, or backspace. Hey, what is event test 0? Okay. Does it really work? Okay, initialize the library. I think should we? We have to print that out to the screen. We didn't print that out to the screen. Yeah. Send as input buffer. Yeah, something like this. Print %s. Does it really work? Input buffer. Yeah, wait. Let's see if if it take my keyboard. Oh wait. Wait, what didn't I clear the... Oh, okay. Update in how do I have it update in real time? How about %C? How do I get it updated in real time? The string. I think we can try this way. Better approach string cat. Yeah, we can append input buffer. How about we print that, print that in the real time. Delete work. Yeah, I think a %C. Event test. How about doing something like this? Yeah, let's do something like this. No, that's way too much. Yeah, let's try it this way. No swap, good. Oh, this is %S. Let's do 0. Wait, should I do something like this? Okay, oh, something's not right. Something is not right. Yeah, let's just use the chart input buffer. Event key dot key 0. To update in real time. Can I update it in real time? Yeah, how do I update it in real time? Can I update it in real time? Send as input buffer. Can I update it in real time? Oh, wait. Adjust. Oh, my bad. That's a 0. Wait, oh, my bad. What? No, stop. Oh no, it doesn't stop the input, it's just going forever. Oh, yeah, because I didn't break it. I didn't break it. That's why. My bad. I mean, what? What? Why is it, wait, does it typing forever? Oh, this one update every frame? Ah, okay, understand. How about I, yeah, do something like this. Oh, it's not broken, it just, why does it run multiple times? Why does it run multiple times? Event key down. Do we need event key up to counter that one? Something. More keyboard input. Oh no! No, my phone shut down. Oh man. Oh well. Oh no. That is no good. How do I do it? Oh well, let's figure it out by ourselves. Event key down. Keyboard down. Oh, I think I understand. How about like this one? How about this one? No. my bad. I think I think I can try to strcat. We have a established function strcat input buffer test, something like this. Wait, let's open the terminal again. Why is this longer? Huh? Okay, I think something's not right. Something is not right. Oh, something is... Update in real time. Yeah, something is not right. Oh, I'm so tired. Wait, let me open my thing. Okay, yeah, let me try again. Okay, let's
Hey, what's going on, folks? It's Mike here, and welcome back to my SDL3 programming series. In today's episode, we're going to be taking a look at input again, but we're going to be looking at a specific function called getKeyboardState, which is really handy to use. And if you followed the previous episode on handling input, this is going to be another complementary operation. And it's going to especially be useful for things like game programming, where you want to handle different keys that might have been pressed at a different time, and so on. So anyways, let's just go ahead and dive into it and see what this getKeyboardState function is. Now, in the previous video, we basically learned about the event loop, which is for, well, handling events, and then we learned about sort of querying the different event types that happen, and then if keys were pressed, and so on. And I sort of mentioned that, well, if you want to see if two keys...
use key. Oh wait, is that a test, right? How about SDL? Oh wait, add chart input buffer event key. Yeah, how about something like this? Can we? Huh? What? No. It's still not working. I think something is wrong. Something is not right. Yeah, something not right.
pressed, or if I hit shift and the letter L or something, I might need to get those key codes. How would I handle that? Well, it turns out there's a really handy function here called, if I go in the complete API index and I search for get keyboard state here.
Oh wait, how about SDL log? Wait, how about Why is D percent D? Percent C. Key. Does it work? Wait. Just want to test a little bit more. Yeah, I think so far this event worked, but this one is not right. Sensi. What about Sensi? A. No, that's not it. Percent D. How about test? Test like this instead of test dot test. Yeah. Percent S. Take the first one, only the first one. Wait, percent S. Wait, how about 0% C? We'll only want one character. Only first one character. ADF. ADF, ADF, ADF. Hey, it worked. But why does it do it multiple times? Why does it do it multiple times? I don't know.
And you can see there's a bunch of interesting keyboard functions, but get keyboard state is the one I want here. And this basically gets a snapshot of the current state of the keyboard. Okay, so let me go ahead and show you how to use this. And basically what I want to do here is, first and foremost, I want to get the pointer to the array of key states. Okay, and I can do this basically wherever I want. So the pointer return is a pointer to the internal SDL array, right? SDL is already managing this for us somewhere, okay? It'll be valid, this pointer that I get back, for the whole duration of the program, right? So this is something I can just do here. And again, it looks like this is a array of bools. So let's just do keys or something like that. And the pointer itself is what I should say will not change here. So get keyboard, oops, let me make sure I do this right. Keyboard state. And then for the parameter here, if it's non-null, I receive the length of the returned array here. So I'm using C++ here. I'm just going to use null pointer here. But basically the goal of this function here is just to return a pointer to some internally managed array here in SDL that always tells me if some key is being pressed up or down. Okay. All right. And it's just going to give me a true or a false value here. All right. So let's just go ahead and compile this much here. Let's see here what I did here. Oops. It says invalid conversion from const bool to bool star. Okay. Let's be very specific here. Const bool, right? I can't change that pointer. There we go here.
Okay. Apparently this one is wrong, so we can use strcat input buffer event test test 0. Yeah, this one should be more correctly. Okay, I think I figured that out, I guess. No. Incompatible integer to pointer converting charge to constant charge. Oh, does it? Oh, sometimes it's kind of oh, it does not clear the input. It does not delete the input. Oh, yeah, I think the problem is these two functions. It didn't do it correctly.
So you make that mistake. Good job, C++, being a little bit strict here. Okay, now how do we actually use this though?
Okay, yeah, just place it aside. So apparently the problem is delete work right here. I think it doesn't work correctly for this one. It's a little bit off. How about I delete this memo? How do I constantly printing the thing outside? Oh, so if it's only use this printf only if this one only if this one is triggered. Oh, what? Oh, oh well, this one is not correct. Yeah, this one here is kind of wrong. Apparently. Yeah, that one's not correct. Does string cat work? cd window project, and we're going to compile that again. Why is double M? Huh? Oh, I guess this one's not. Add the last character to the string. Oh wow. Okay, so I think the problem is how we handle the string right here. Yeah, that's how we handle the string is not correctly. How is you have to re-handle string?
Well, we need to use this with the scan code values here, right? I want to check if some key was pressed up or down here. Okay, so let me scroll down here a little bit here. And let's go ahead and see here if I called this keys. And, well, this is an array here, right? I mean, this is a pointer here. It's giving us a managed array here somewhere. So I basically want to check some key and some index here, like this, and just say if keys, equals true, right? Because it's a true or false value. Say 111 key was pressed. Okay.
Okay. Let's remake this function right here. Add character to the last one, so get the length of the string. So the last word is the last word should be wait, how about let me just do adjust input buffer event key dot key 0, like this. Yeah, shut it down. Subversive value is not an array. Pointer or oh wait, my bad. Test, it should be test. Yeah, it should be test. Test. Okay. Min. So apparently that's still the same problem. How do we add the string to the add the character to a string? How do we add new character to? No. To the end of the string. How to add character to the end of the string in C. Yeah, so append a character to a string. So yeah, I think I need to watch this one. Yeah, let's make a new video. Upload.
In this video,
Yeah, I should not I should concentrate. That's not multitasking.
to learn how to append a character to a string using C. So first we'll declare a char array called buffer of length 100, and we'll store into this char array the string subscribe.
Yeah.
Then we'll append a character to the string. Let's say the character R. We'll declare a char variable called character, and we'll store into this char variable the character lowercase r. We can actually use the strncat function inside the string.h library to solve this problem. So up here, we'll include the string.h library with $ include string.h. Then down here, we can call the function. So we'll call strncat. Now typically, the way this function works is that we pass it a destination string, a source string, and some maximum number of characters to append from the source string onto the end of the destination string. So just to see, let's create a char array called source, and we'll store into this char array the string $A. Then down here, we'll pass strncat buffer as the destination string, and source as the source string, and 2 as the max number of characters to append from the source string to the destination string. Then down here, we could output the destination string stored in buffer afterwards. So here, we'll call printf, and we'll pass it a string with %s to output a string, followed by \n for new line, and we'll output buffer here. Then, if we save, compile, and run the program, we'll get here subscribe, followed by 2 A characters.
Oh.
And that's because we only appended the first 2 characters from the source string to the destination string. Now, when we call strncat and we pass it buffer and source, what's really being passed is the memory address of the first character in these strings. So really, this function here is accepting the memory address where a character is stored. And what we could do is pass in the memory address of this character here. So and character will pass in the memory address of this character here in memory. Then what we'll do is append only that one character to the string. So here we'll have 1 as an argument. So just this one character is going to be appended onto the end of the string. Let's delete this. Then we'll save, compile, and run the program. And we do get here subscriber. So it is working. Now to understand what's happening when we call the function, let's remember that each character in this string is stored at an index. So for example, this lowercase s is stored at the index 0, lowercase u is stored at the index 1, and so on for the rest of the characters in this string. And at the last index in this string, we have the special null terminator character that ends the string. And when we call the function, the character lowercase r is going to be written here, and the null terminator is now going to be at the index 10. So the array that we store the string into has to be large enough to account for this additional character. Now, if we're using something called dynamically allocated memory to store the string, it's possible to actually increase the size of where we're storing the string. I'll post a link in the video description to a video covering how to do this. Check out portfoliocourses.com.
Okay. So that's clear. Lots of questions in my head. So we can use strncat. We can use input, buffer, event, test 0. That is the key that we enter. Only one. Yep. Okay. So if that is the case, we need a memory address of that. Yeah, memory address of that, because I think it worked, but this one is the problem. Can we print it out here? Can we print it out here? Oh no. Yeah, that's not it. Oh, okay. Hey, the print in here is not really good. Delete the last word. Shift the character. Delete last word. Wait. Of a string in C. Delete last word of a string in C. Remove the last character in the string. I need to.
Driving revenue used to take all of this and that and that, this, oh yeah, and that. Now it just takes a.
In this video, we're going to learn how to remove the last character in a string using C. We'll first declare a char array called string, and we'll store into this char array the string ABCD. Now remember that in C, each character in this string is stored at an index. So for example, lowercase a is stored at the index 0, lowercase b is stored at the index 1, and so on for the rest of the characters in this string. Now at the index 4, after the last actual character in the string, lowercase d, we're going to have the special null terminator character which terminates the string, represented with \0. Now because the null terminator character ends the string, to remove the last character, we could just store a null terminator character one index earlier. One way to do this would be to find the length of the string using the strlen function found inside the string.h library, which we'll include here. So if we call the strlen function and we pass it our string, it's going to return the length of our string, not including the null terminator character, which in this case is going to be 4, because our string has 4 characters. So if we subtract 1 from this number, that's going to give us the index of the new place for the null terminator. And what we'll do is just put that null terminator character at that index. So we'll assign to that index the null terminator character. Then if we output our string using printf and %s to output a string, followed by \n for a new line, and we output our string here, then if we save compile and run the program, we'll find that our string is now just going to be ABC. And here we get ABC. Now, one other way we could do this is to manually find the null terminator character. What we could do is have an int variable that we initialize to 0. Then we could have a while loop with the condition that while the string at the index I doesn't equal the null terminator character, we're going to increment I. So I is going to begin at 0, and we'll continue to increment I with each loop iteration until I reaches the index of the null terminator character. Then down here, we could just assign to the string at the index I minus 1 the null terminator character. Then again, if we save compile and run the program, we'll get the string ABC. So this is how we can remove the last character in a null terminator character.
Thank you so much. Thank you so much. Yeah, I think we got this one wrong. Just that work. Yeah, this one should be wrong. Cool. So it'll be passed in here. Make remove last work. So do we? I think we don't need this function. Wait, no. Let's remove the last work. I think, yeah, delete the last work. Wait, I think, yeah, it should make this function right here. Yeah. str. No, yeah, I think we don't need this. I just need. Yeah, it's so simple that. Okay. Input buffer. Lane. Input buffer. -1 equal to no terminator. Equal to no terminator. Remove the last work. Last work. It's just this simple. I think the printf on every of this only work if we if we pause if it was a function that is an attack input anymore, or otherwise it's going to override the printf. Input %s new line min input buffer. Yeah. Oh, so it's just that simple. I don't have to do anything. Input min. Yo, it work. Min. If we press enter, okay, it worked. Oh, yes. So I understand how it works. So I think now we just need to display it into the screen. Yay! It worked. Thank you. Thanks everyone. SDL enter and else if event key else if equal SDK return, just the enter key, escape space, Kiko enter return. Yeah, I think it should be the return equal SDLK return Then we're going to start the test input. If we press that, so it's going to just like we type something and we press enter, it's going to not taking the input anymore. Yeah, SDK start test input window, accepting input equal a false, and I'm going to use this one. Copy. Stop it. Test input. Okay, so it works something like that. Here, let's see if that works. Go here. Type in min. Enter. Yeah, min. Enter again. Does it take anything? Nope. Okay. 1 2 3 4. Yes. Type in me. 1 m. And no m. Cool. So far so good. So far so good. So far so good. So far so good. SDL log. Yeah. So this work. And cat. Wait. SDL. Does it have its own function? Hey, it had its own function. Does it? Yeah. Let's use all the SDL function. So it's in the long run, it's going to be compatible with every other machine. SDL lcat std inc connect key string. Cool. Okay. Include EF3 SDL std in h stdio. I don't need this one, and yes, certainly not this one also. Goodbye. stdio. Yes, does it work? Huh. std str. Wait, oh yeah, that's wrong function. str lcat. Min. Does not work. Why? Huh? Oh, so this one doesn't work. cpy copy a string. Masking. Destination. Source. Second node terminated string. strmcat in I think instead of How about let's not using this one, let's make our own. Because hey, I think they have an example of the append. Yeah, I think an example of append. Yeah, I think we don't have to use it function. We can make it our own.
Only appended the first two characters from the source string to the destination string.
Yes.
Now, when we call strncat and we pass it buffer and source, what's really being passed is the memory address of the first character in these strings. So really, this function here is accepting the memory address where a character is stored. And what we could do of the function is one character.
Wait, str ncat. Wait, it should work, right? Why is not working? Implementation. Oh, wait, here. str ncat connecate string. How does it work? Full. str ncat implementation. C. strcat ncat locate std dep. Oh, we move pointer to the end of the destination string. Locate the end destination. Find a node terminated. Okay, right here. How do we implement the station cat? Yeah, so let's see it. So first of all, yeah, how do we S3 in cat? Yeah, something like this. Oh, it's almost 2 hours. Pointer to a no. So let's make a pointer. Pointer to for the first string and second string. Create a copy of S1. Destination equal S1. Find the end of destination string. Mention password. Now append the source. Append the source string character until not get. Until not get no character of S2 y minus 1 in the source string. Return s1. What is n? Oh, n should be the level. N should be the number of characters that we want to append. If this string have like a 5 character, and we only want to append like 2 of it, then we can type it in here. Oh. And cat. What? This feels kind of magic to me. Yep. Destination password equal, yeah, s2 password. Yeah, this feels kind of magic. Append. Okay. Let's see. Charge my encat, my string append to string, charge the first string 1, const charge string 2, sign it in n, and sign it in pointer to the, make sure that the pointer is not null. Or st, oh wait, my bad, string 1, return null, copy, make a copy of string 1, char destination equals string 1, find the end of the destination string, the copy string of string 1, while equals string 1, no, destination, yeah, and destination in so it's going to move up it's more like, so for example, we have this string right here, right? So the destination, the copy of destination will point to the first character of that string. If we increase it, it's going to move up this way, increase it and move to up until it find the wait, this one wrong, until you go to the end at the end, see this no terminator. 0. Yeah. Now we're gonna append the source string character until no character or string 2 or hit the amount. So string limit at n to copy of n. Wait, 1 sec. Okay guys, I'm back. Just check my phone really quick. I hope it won't be too hot. Yeah. Okay. While okay. While and minus minus if not this one, not the destination, not the if the destination, if the pointer destination equal to the string, the pointer of string 2 plus plus returns string 1. Append the no nation equal. Yeah, I think by doing this way, it will run on every single machine without rely on the function. Yeah, maybe that work. Terminator in the end of the string, and we're gonna do return string 1. Hey, can you let's add ChatGPT about this. Can you explain this in to child 1? Copy character and watching the no terminator. Break the loop, end time, decrease it, copy character, copy one character from S2 to S1. Copy it. So this one will equal to this one, and it's going to increase the pointer upward this way for both of them. Return the value assigned. If we so for this one, if we copy the no terminator, the condition it will trigger the condition and return it. The limit, the end of the string. Oh wow, so that's how it works. Okay. Append to string input buffer the address of the event of the key that we just type in. Just one. Yeah. Q. Okay, let's see if that works. Main, enter, main, enter again, 1 2 3 4, enter again. Hello, my name is Min. Hello, my name is Min. That's my name is 1 2 3 4. My name is Khan. My dad name. Cool. So it worked perfectly fine. If I hold really long, yeah, it's deleted. Cool. So far so good. Yeah, I think I don't want to use the standard library because it might add the extra overhead to here. So I think by trying to use the built-in SDL3 and kind of implement our own function, I think we have more understanding basic of the C, and it will reduce overhead. Let me ask you quick. Does this code scalable and maintainable in the long run? We just add ChatGPT this one without change. Better approach use struct app stay. Append too risky. No bound checking. Input buffer overflow. Okay. Oh, okay. It's getting messy. Resource is ending incomplete. The font. Oh well. Too much global stay. Yeah, I will try to work on it, but let's make sure this one input buffer append to string side t if the length is less than tracking namespace security bug. Oh, and I have to take in account of the input overflow. Yeah. Okay. Gotta check for site T. Then input buffer. Yeah, we gotta check if the length, the input length is less than math -1. Oh, wait, my bad. Not this one. It should be this one right here. Wait. Should I declare every time the event trigger? Should I declare? It's fine. Okay. Yep. To string. STL lock math input buffer is delete character. Yeah, cool. Character. Huh. Okay, yeah, that's what if we do like 20. One, two, three, 4, 5, 6, 7, 8, 12, 13, 14, 15, 16, 18, 19. Oh yeah, how about this one? input, accepting input. Let's try it once again. Okay. Okay, cool. 1, 2, 3, 4, 5, 6, 7, 8, 10, 12, 13, 14, 15, 16, 17, 18, 19. Yeah, 19. So it's work. Yes, the safeguard. Good to know. And the text input. Oh, okay. So let's group this one into a function. Okay. STL app event. Yeah, I think I will. Okay. I think I will this one to a struct next time. Yeah, that's what I do. Okay, guys, that is it for today. So far, so good. I will refactor it later. And as for feedback, if you have some feedback, just type it in a comment. Thanks for watching, everyone. Bye. Bye.